I make art about science, so my work takes me out of the studio to exciting and unpredictable places. On this project, I was on a ship at sea for 3 weeks. There, scientists worked round the clock to uncover the mysteries of the ocean. Our project, the Atlantic Deepwater Ecosystem Observatory Network, collected acoustics data along the eastern seaboard of the United States. My artistic practice grows out of an intense curiosity about the ways in which our society is supported by science and technology. I use textile techniques borrowed from high fashion to connect the viewers and create richly textured, stitched and beaded surfaces. Light only penetrates a few hundred meters underwater, so visibility falls off dramatically, and the kinds of visual observations that scientists use to study land ecology is not particularly illuminating. Studying what's happening under the ocean requires a different approach. Ocean acousticians talk about soundscapes. A soundscape is just like a landscape. It's a picture of what's happening in the ocean environment using sound instead of images to describe the ecosystem. Project worked on both active and passive acoustics, and this was a natural divide and inspired me to create 2 large-scale textile pieces. Active acoustics uses sound to visualize what life forms inhabit the water column. A ping of sound is generated from the ship, and I've illustrated this on the art piece by orderly waves of equations, and those sound waves actually bump into life forms in the water column. The returning sound waves, which are intentionally illustrated in a messy fashion, send back a unique sonic signature. Active acoustics captures data about the world's largest daily migration. The deep scattering layer, 200 meters below the surface, is a mix of tiny life forms called zooplankton. They're small animal life forms that drift on ocean currents, mostly made up of small fish and squids. They travel a daily migration to the surface of the ocean at sunset, where they feed all night, and at dawn they scoot back down into the gloom a few hundred meters below the surface. This daily migration inspired the stitching in the top half of the ocean acoustics piece. At the bottom of the active acoustic piece, I've embroidered a few species of phytoplankton. Phytoplankton supply about half our planet's oxygen, and they sequester tons of carbon dioxide. Rising sea temperatures due to climate change are altering the abundance, the distribution, and the seasonality of phytoplankton throughout the oceans. They're the foundation of the entire ocean food chain. The ramifications of reduced populations of phytoplankton will influence the marine food chain, commercial fisheries, and the wider marine ecosystem. Because of limited visibility, marine mammals and fish are highly adapted to producing and perceiving sound in the ocean. Animals rely on sound for many purposes, such as navigation, maintaining social interactions, finding food, and attracting a mate. Passive acoustic data is normally presented in a timeline running from left to right. However, in designing this piece, I wanted to express the idea that the data is collected in 360 degrees. So I chose a circle within a square design. I interpreted the passive acoustics data using areas of dense stitching and beading on a rich silk Dupioni textile. Historically, these kinds of hand processes and materials were used in the clothing to denote social status. Creating art in these techniques helps to elevate the message of the science in the work. So I've also included in the very center of the piece, the most important real estate in any artwork, an equation that's central to interpreting all acoustics data. This equation is the link between the environment, temperature, pressure, pH, salinity, and pressure, and the acoustic data that allow scientists to make conclusions based on these acoustic measurements. I've embroidered equations in the border that reference ocean acidification. A proper pH balance is crucial to the survival of marine life. As the planet warms and the rise in CO2 levels contribute to an increase in ocean acidity, this rise in acidity means that less calcium carbonate is available to organisms for building shells and skeletons. Both science and art are deeply human endeavors, and there are strict rules that define what activities get to be called scientific. But before an experiment begins and after the data has been analyzed, there's plenty of room to connect science to human experience. It's hard to connect with what we can't see. Making the data visible helps us make data-supported decisions to protect ocean health.